Ladies and gentlemen, day 106, types of rocks. Starting off our unit on rocks. We looked at minerals before, and minerals were a very special kind of a thing. We're now looking at the more general kind of solid stuff out there, just ordinary rocks. The purpose, you're going to learn 3 different types of rocks and how they can change. All rocks can be placed into one of these 3 categories. And this is a very basic idea of geology. We're going to be using a lot of these terms throughout the next couple chapters, and so we need to know these terms and exactly what kind of rocks we're talking about with these 3 types. So your success, you'll be able to look at a rock and say, aha, I know which type this is. It's either metamorphic, or it's igneous rock, or it's a sedimentary rock, one of those 3. So let's first look at notes. Remember that the stuff that we've been looking at before were minerals, and they were very special kinds of solids. They had crystal structures, constant chemical makeup, and were inorganic. If it doesn't classify, or if it doesn't satisfy those 3 things, it's not a mineral. We just call it simply a rock, and that's what we're going to be looking at today. So, igneous rocks are the first kinds of things we're going to be looking at. Igneous rocks form when melted rock cools and forms patterns of atoms called crystals. A lot like the minerals that we've been talking about, but in this case it's a little bit different because the crystals are going to be different in different locations of the rock. There'll be different kinds of crystals, different sizes of crystals, different shapes of crystals. It's going to be a little bit more chaotic, but yet they're still going to be crystals. If it is a melted rock under or over the ground, that's lava, and that's going to be called an extrusive igneous rock. The reason why this is an important difference here is that if it's lava, it's going to be cooling relatively quickly over a short period of time. It's exposed to the air, exposed to wind and rain and all that kind of stuff very quickly. Sometimes the lava comes up under the ocean, so the cold water really freezes it really fast. So a short period of time to turn into a solid rock, and since there's only a short time, it's going to create small crystals. The atoms do not have time to arrange themselves in nice big crystals that are all pretty looking. They're going to get frozen in place really fast, and usually they're not going to be very organized, and so small crystals are formed. Here we have 3 pictures then of different kinds of extrusive igneous rocks: pumice, obsidian, and basalt. Obsidian is really kind of pretty. It looks like glass. Very, very smooth, very, very shiny. Basalt is the stuff that forms under the ocean. Most of the ocean floor is basalt covered with gook. And then we have pumice here, and we have an example of pumice in class. I'll show you. It looks like it has all sorts of frozen bubbles in it, like Swiss cheese kind of a thing. And then we have 2 pictures of what's called intrusive rocks. Let's look at those in our notes. Line number 6, if magma cools. Remember, magma is the melted rock under the ground. If we have magma cooling, the rocks are called intrusive igneous rocks. And since the magma is underground, it cannot cool off very well. It has all the insulation of the dirt and grass and stuff all around it, and so therefore it cools very, very slowly over a long period of time. Since it is liquid for a long time, that allows the atoms to come together to form large crystals. And things can get kind of pretty looking. In this case here we have granite. And if you look carefully at this picture, you'll be able to see large black blotches and white blotches. And when that's all polished and everything, it looks very pretty, and we make countertops out of it, or sculptures of various sorts. Line number 9. Sometimes bubbles of gas are frozen into the rock. As the liquid turns into a solid, we call it freezing, even though it doesn't necessarily get cold. But if there are gas bubbles in the lava, and then the lava cools into a solid, the bubbles are going to stay in there, like the pumice. And it's going to make the rock look like Swiss cheese. If you ever see this, you know it's got to be an igneous rock. No other form of rock will keep these bubbles in place. Okay, page number 1, done. Let's look at page number 2. Start off with 2 pictures of what's called sedimentary rock up on top. We have something called conglomerate here, and the one that has layers, that's going to be a type of sandstone. Okay, notes. First of all, sedimentary rocks form when sediments are compacted and cemented together. We haven't really talked what sediments are, just really, really tiny things. It could be dirt, sand, silt, any kind of tiny, tiny particles made in lots of different ways. Okay, they're gathered together by different means and compacted and cemented together. By compacted, we mean squeezed, and that's usually done by being buried down deep. As more and more stuff gets put on top, the lower layers get squeezed. By cemented or cementation, we mean that they are glued together by some natural process. Lots of different kinds of natural glues can form and stick these things together. Examples of sedimentary rock are sandstone, when, believe it or not, we just simply stick sand together. That's why we call it sandstone. Imagine that. Okay, line number 19, salt. Lots of different kinds of salts. You may have heard of the salt flats out west, where the ground is very, very flat, and it's made out of this layer of salt that you can actually just kind of mine from there if you wanted to. Anyway, we have pieces of salt stuck together after the water's evaporated. Another kind of sedimentary rock are fossils. Fossils are plant or animal remains that are stuck together after many, many years. In order to make a fossil, you don't just simply have some kind of a critter fall over dead and after a short time it's a fossil. You have to have very special conditions in order for fossils to develop. The most important one is that you have to have the critter get buried very, very quickly. One of the reasons is that otherwise scavengers are going to come around and pick up the pieces and carry it around, and they're not going to get found all together again. Fossils don't have to be just the bones or the tissues of the organism. Sometimes they're just simply the imprints of the organism. For instance, if a dinosaur is walking around in the mud and leaves a bunch of footprints, and then the footprints get filled in with sand and that turns into sandstone eventually, well, we'd call those imprints, the footprints, a fossil, even though there's no actual bones there at all or anything. Number 22. In fossils, the atoms of the organism are gone. They've been replaced by minerals. When the organism is buried and water percolates through the ground, it will dissolve parts of the organism, carry those atoms away, and in their place, minerals that are in the water will get deposited. So slowly it switches out from the atoms of the organism to be atoms of these minerals. And eventually all of the animal or all of the plant is gone, and we have just minerals. And the minerals have the exact same shape as what the organism used to have. So that's why we can study the organism still. But in these cases, for it to be a fossil, there's nothing left of the actual organism. Now, there have been cases where it appears that the original molecules of the organism are indeed still intact. And so when they're holding something that looks like a bone, it actually really is a dinosaur bone. It's not fossilized at all. These also include blood vessels or blood cells of dinosaurs. It's a little bit controversial. It's not accepted all the way yet. There's a 14-minute video by the news program 60 Minutes that I want you to see right now. So if you'd pause the video of these notes and open up another tab and watch this 60 Minutes that is on YouTube, that'd be kind of interesting. And then you restart up this video to finish up the third page of notes. Okay, you should be done with the 60 Minutes video right now, and you will be responsible for knowing stuff from that video on the next quiz. Okay, the next topic are the third kind of rocks called metamorphic rocks. Metamorphic rocks form when an old rock, an old igneous rock, old sedimentary rock, or an old metamorphic rock is exposed to heat and pressure. Now, it's not hot enough to melt the rock. It's not enough pressure to crush it into little smithereens, but it is enough heat and pressure to sort of cook the rock so that the crystals and other things are taking slightly different forms. Metamorphic rocks are formed slowly when the pressures and temperatures are high enough to rearrange atoms. This allows the atoms to rearrange into new rock formations. Sometimes the metamorphic rocks are classified as foliated, which means that there are layers of different minerals. It actually looks striped to a degree. Sometimes the metamorphic rocks are classified as non-foliated. Those are ones that do not have any distinct layers of minerals. It looks all uniform. So here we have three diagrams showing 3 different ways that 3 different kinds of metamorphic rock can happen. Over here on this side we have granite, which is an igneous rock. We talked about that before with the large crystals of black and white in there. Okay, if you put that under a lot of heat and pressure, it's going to turn into a metamorphic rock called gneiss. It is foliated, so you can see the stripes that are in this rock. It's kind of squished the crystals here into flat pancakes. The next kind starts off with sandstone, a sedimentary rock. We have some lines there, some layers. And then we have heat and pressure, and then all those lines and layers disappear because of the heat. It's now a metamorphic rock. It's non-foliated, meaning that it does not have the stripes anymore. It's called quartzite. And then lastly, we have shale, sedimentary rock, very dark and black. It's kind of uniform. It sort of looks like coal. Put that under a lot of heat and pressure, and guess what? You get another black rock. Looks a lot like coal. It doesn't change a whole lot, but experienced geologists can tell the difference. This slate stuff, that's what they used to make chalkboards out of. They still use it for a lot of stuff, including roofing materials for very fancy houses. You can have tabletops made out of it as well. You can also do sidewalks, pavers, and that kind of a thing. Number 27, tektite is rock made from asteroid strikes. What kind of rock would that be considered? Okay, when an asteroid hits the ground, it can actually produce enough heat in the explosion and collision that it actually melts the rocks and tosses them around. And that melted rock turns into solid rock again, and so tektite then is igneous. That's from melted rock. Fulgurite is made from lightning striking sand. What would that be considered? Well, again, the lightning is going to be melting the sand, and then when that cools, it's going to make the fulgurite. So cooling melted material is going to be igneous. And lastly, coprolite is rock made from fossilizing dinosaur poop. What kind of rock would that be? Whenever you have fossilized stuff, it's always going to be sedimentary. It's never going to be igneous or metamorphic. The heat involved in melting rock is going to destroy any kind of plant or animal material. And the heat and pressures involved in making metamorphic rock will also destroy any kind of organism stuff. And so you're not going to see fossils in either one of those two. If you see a fossil, it is guaranteed to be a sedimentary rock. Okay, that's the end of the notes. That went pretty quick with about 12 minutes. What you're going to be doing for the rest of the period is taking this picture here, and you're going to be drawing all sorts of pictures in here. You're going to be drawing labels and words and arrows and all kind of stuff. You're going to be watching this video right here, Bulldog Earth Science Day 106 Rock Illustration on YouTube. And you'll follow along with my directions there, and you'll fill this all in, and that will be your homework for today. When you're all done with this, you'll show it to me, and I'll mark it down in the computer right away. Thanks much.